All right, so let's boldly go into stuff that you've never seen before this year. And let's see how this goes, right? Can't go bad, right? All right, so topics we haven't covered yet. Okay, so this is kind of a lie to my honors kids because you did see this. My regular geometry, this is coming up. So inscribed angles. So when you take a look at an inscribed angle's vertex is on the circle. That's all. So in this picture here, angle C is an inscribed angle because C is on the circle and it intercepts arc AB. So inscribed angle C intersects arc AB. Now, the inscribed angle theorem says that the measure of the inscribed angle is equal to half the intercepted arc. So in this picture, angle B is the inscribed angle and arc AC is the intercepted arc. The measure of angle B is half the measure of arc AC. Now, you can also think of this from the arc's perspective. Say I wanted to find the measure of arc AC. Well, if I want to find the measure of arc AC, I'm going to take 2 times the measure of the inscribed angle. So be aware that both of these relationships can be used. Big idea here. State test likes inscribed angles. These are some ideas from the inscribed angle theorem. So 2 inscribed angles that intercept the same arc are congruent. So if you notice angle A here intercepts this arc. Angle B here also intercepts the same arc. So of course, they're each going to be half that arc, so they're going to be congruent. Okay. In the second one, if you have a diameter drawn in your picture, remember it creates 2 semicircles, one here and one down here. Angle C, if you follow its sides, angle C, whose vertex is on the circle, ends at the endpoints of the diameter. So it intercepts this semicircle. Well, remember, a semicircle is 180 degrees. An inscribed angle is half of that arc. Half of 180 is 90, right angle. And then last but not least here, this is something that they like to test you on as well. So the opposite angles of a quadrilateral inscribed in a circle are supplementary. So this quadrilateral is inscribed in the circle because all 4 vertices are on the circle. So if we compare angle A and angle C, they will be supplementary. The measure of angle A plus the measure of angle C will be 180. The same thing with angle B and angle D. The measure of angle B plus the measure of angle D will be 180. So that's an idea you should try to remember, okay? Just because of the circle being inscribed, or the quadrilateral being inscribed in the circle. And then lastly, this one not so used, but again, if you have a tangent and a chord, they create an angle. So in this case, this chord and this tangent create angle C. It opens up to this arc. It's going to be half of that arc. Same thing with this chord and this tangent opens up to this arc. It's going to be equal to half of that arc. So again, same kind of relationship as the inscribed angle theorem. All right, huge one. Biggie. I feel really bad that we did not get to this. The equation of a circle. This is the equation of a circle. X minus h squared plus y minus k squared equals r squared. H and k are your center and your radius is r. Now notice in the problem it says x minus h, but your h is a positive. This symbol, and this symbol are going to be opposite of what they truly are. Opposite. So for instance, say my equation was this: x minus 1 squared plus y minus 2 squared equals 9. All right, so this is my equation. So in this case, the center would be this h and this k. Positive 1 and positive 2, opposite of these signs. And this 9 is not the radius, that's the radius squared. So to find the radius, we simply take the square root, and the radius would be 3. Now, what about this one? What if it was x plus 1 squared plus y minus 2 squared equals 9? Well, now this is your h and that's your k, but now it says plus 1. So now your center is at negative 1, 2. Notice it's opposite of what it says in the formula. And your r squared is still 9, so you take the square root and r is, 3. Now be aware, okay, that you can type this equation in and it'll graph it for you in Desmos Graph and Calculus. So let me go there right now and I'll show you what I'm talking about. Okay, so this is the Desmos graphing calculator for the state test. Let me go ahead and type in that last equation. So parenthesis x plus 1 squared plus parenthesis y minus 2 squared equals 9. And notice there, it does circle. So remember, I talked about you don't have to have it solved for y. You can type in any equation and it'll graph it for you. Now, remember, I like to zoom out. So now the problem is you got to try to, eye up the center. So it looks like the center is here at negative 1, 2. So if I type in negative 1, comma 2, I can label that as the center. Center, CE. There. Okay. And there you go. And then you can count the radius just 1, 2, 3. So it's not 9. The radius is not 9. It's the square root of 9. All right. So there you go. Okay. So that's a biggie. Like I said, I'm sorry that we did not get to cover this ahead of time. All right. So again, you want to make sure you pay attention to this. And I don't believe this is on the reference sheet. So you got to try to memorize it. But again, it's just like the distance formula, right? If you think about it, it's the same thing. There's your right triangle. This is x to h. This is y to k. And that's your r squared, which is your d squared. Okay. All right, cool. Okay, let's go ahead and do this as well. Oh no, let's stop. No, let's do this. We'll do this and then we'll stop on probability. So 3D. So now this is chapter 11 talking about three-dimensional. So a polyhedron is a space figure or a 3D figure. The polygons are called faces. The segments are called edges and the corners are called vertices. So be aware of the notation or the vocab there. So when you look at a cross section is a 2D slice of a picture. Now, this right here is called a triangular prism. It's a triangular prism because you have two triangular bases here and here, and then the other faces are rectangles. Because you are cutting it vertically, parallel to the bases, your cross section is a triangle. Okay. If you were to cut it horizontally, you would see the cross section would be a rectangle because the other faces are rectangles. So your cross section is going to be one of the shapes making up your 3D figure. So keep that in mind. Okay. The next topic is called solids of revolution. So if we have a line and we have a 2D figure on that line, what's going to be formed if I rotate this rectangle around this line? Well, you only have three choices because there's only three figures that we know of that involve circles. And your choices are a cylinder, which is like a pop can, a cone, which is an ice cream cone, or a sphere, which is a ball, right? So if I take this rectangle and I rotate it, right? Take it and I rotate it down and back up, down and back up. You can see that the edges become circles, and that's how you get the cylinder. Same thing would happen with a triangle. If you start with a triangle for a cone and you rotate it down, right, you get that. And same thing with a half circle or a circle. If you start with a half circle and you rotate it, it would just keep rotating around and you'd get this circle and it'd be a sphere. Okay, so keep that in mind as you're doing these solids of revolution. Again, very common multiple choice question on the state tests. Okay, so now let's really focus on what a prism is. So a prism has two congruent parallel faces, which are called the bases. The other faces are the lateral faces. They're going to be rectangles. So your lateral faces are rectangles for your prism. So in this case, this is a pentagonal prism. Here's the top base and bottom base, and the rest of the sides are the rest of the faces are rectangles. Here's a triangular prism. Here's the top. Here's the bottom, and then again, the rest of the faces are rectangles. When you're trying to find the volume of a prism, you take the area of the base. That capital B is not base. It stands for area of the base. So you need to know what shape this is. You got to find its area. Once you find its area, that's two of the dimensions. Then you multiply by the height, and that's how you get your three dimensions. Okay. Now, for a cylinder, you can use the same formula, but because the base is a circle, instead of capital B, we replace it with pi r squared because that's the area formula for a circle. Again, you will see these on the reference sheet. So again, these are on the reference sheet, the formula sheet. pyramid is a polyhedron with one face, okay? So that's the base as well. And then you have this top vertex. All of the lateral faces are going to be triangles because they all come to a point, okay? Now, in a pyramid, you have what's called the slant height and the height. You're going to see when we talk about volume, you need the height. Now, sometimes they do give you the slant height. So if you see here, you create this right triangle. Sometimes you have to use Pythagorean theorem to find the height from the slant height. I don't think you will on the state test, but just be aware that that is there. Okay. So when you find the volume of a pyramid, the volume of a pyramid is 1/3 the volume of the prism. So you just do the area of the base again. Remember that capital B is the area of the base times the height. So find this area multiplied by the height inside the prism. Again, be aware of that slant height. Use the height. So for a cone, again, the shape of the base is a circle, so they substitute pi r squared in for b. Again, all this is on the reference sheet. Okay, and lastly, our 3D figure, a sphere. So a sphere is, of course, a ball, right? It has a radius, it has a diameter. That's the sphere. Here is the volume formula for a sphere, 4/3 pi r cubed. Again, I didn't talk about volume. Remember, volume is units cubed. So that's why this radius is cubed. It's on the reference sheet. I would ask that you not try to memorize this because a lot of people think it's 4/3 pi r squared because they think that that is, what it is, but it's not. It's cubed. It's a cube. So be aware of that. Lastly, when you talk about volumes of similar solids, so if your scale factor is A to B, remember we did A over B in our previous notes, then the ratio of the volumes is simply going to be the scale factor cubed. A cubed over B cubed. And again, that's because volume is units cubed. So be aware of that. Okay, and that ends our volume. So I'm going to stop the video and finish with probability. So one more video to go.